lecture, which is going to be on the unit number 5 on your course outline. It's going to be on the topic measures of relationship. And basically, when we talk about measures of relationship, our focus is going to be on linear regression and correlation. Coefficients. Now, what are our learning indicators for this lesson? We are saying that when we are done with this lesson or this unit, you should be able to state the general form of the simple linear regression equation and define the terms involved. The second one is that we should be able to determine an equation for the simple linear model using the method of least squares and use it to make estimates for the response variable. Then the third one is that we should be able to calculate the correlation coefficient for a given pair of variables, that is, either it is dependent or the independent variables that are going to be given to us. And then when we are done with the correlation coefficient, we should be able to interpret the correlation coefficient that we have been able to calculate, either using the Pearson rank, the Pearson product moment correlation coefficient, or using the Spearman rank correlation coefficient. So these are our learning indicators for the lesson. Now let me start with linear regression. Let me start with linear regression. Good afternoon, students, and you're welcome back to our day's lecture, which is going to be on the unit number 5 on the course outline. Now, unit 5, our focus is going to be on measures of relationships, and then we shall be talking about linear regression. And correlation. Coefficients. These are what we are going to talk about for the day. But what will be our learning indicators for the lesson? The first one is that by the time we are done with this lesson, you should be able to state the general form of the simple linear regression equation and define the terms involved over there. And then we should be able to determine an equation for the simple linear regression model using the method of least squares and use it to make estimates for the response variable. We should be able to also determine or calculate the correlation coefficient of the given variables and also use it to talk about the value of the correlation coefficient. Describe it. How do we describe the correlation coefficient that you are going to calculate? These are the learning indicators for the lesson. And so without wasting much time, let me take you straight to what we call the regression analysis or the linear regression. Now, For linear regression, for the sake of this course, our focus is going to be on what we call the simple linear regression. And when we talk about simple linear regression, it involves only two variables. In fact, if it involves more than two variables, then we are talking about multiple linear regression. But because we are going to talk about only two variables, our focus is going to be on simple linear regression. And I've told you they involve only two variables. And these two variables are such that one of the variables is going to be what we call the dependent variable, and the other is going to be on the independent variable. So for example, if a research is being carried out to find whether a person's age has any relationship with the person's height. Okay, so let's look at it. We are talking about a person's age, and we are talking about whether that age has gotten any relationship with the person's height. So we can denote the person's age by Y. That's the person's age. We can denote that one by Y, and then talk about the height of that person. The person's height to be X. Okay, so these are the two variables we have here. And so normally when they give you the question, if it is not stated that X on Y, but it is framed that calculate this and they leave it like that, then normally it is that the Y becomes the dependent variable and the X is the independent variable. Okay, and so if that is the case, we can use it to draw what we call the scatter diagram. Okay, and so when we come out with the scatter diagram or the scatter plot, then we are going to use it to estimate what we call the line of regression, or to get the line of regression, of which we can use to do predictions. Okay, and so let's assume I am talking about person's age. So in my class, I am doing a selection, and I've taken about 7 students' ages, and I've taken the same 7 students their height. So I've taken the ages of 7 students in my class, and I took the heights of these same 7 students. And I want to see if there's some kind of association or some kind of relationship between the age and the height. The other day, I was teaching a particular class, and I was using this jokingly, that let's assume in a relationship, there's a lady and then there's a gentleman. Now, under normal circumstances, the lady is going to depend on the gentleman. So the gentleman becomes the independent variable, the lady becomes the dependent variable. And you will see that in regression, we are going to have what we call the positive regression or positive relationship. We are also going to have what we call the negative relationship. Now, the truth of the matter is that under normal circumstances, if the guy is going to give more money, buy more clothes, take the lady to boutique, do a lot of things to the lady, then the normal expectation is that the lady is also going to love the guy more. So if the guy is giving more money, the guy is taking the lady for shopping, the guy is doing a lot of things for the lady, and the lady is also loving the guy more, then we describe that one as positive relationship. You will see that the guy is giving more, the lady is also loving. That one is positive relationship. But in a certain situation where this guy is not giving money to the lady is also not loving the guy. You guy, you are not giving money, you are not taking me to boutique, you are not giving me toffee, you are not giving me kebab, and then I'm also not loving you. You see that the guy is decreasing in terms of the things the guy is supposed to give to the lady, is decreasing. And the lady is also not loving the lady, it's also decreasing. This one too is positive, because this one is decreasing, this one too is decreasing. And so this one too is positive. But in a situation where the guy gives more money, but the lady doesn't love, the guy gives more money, the guy has been buying trophy, the guy has been buying kebab, having taken the lady to
boutique to buy more things, but this lady is not loving. You see that the guy's idea, things the guy is giving to the lady is increasing, but the lady's loving is decreasing. This one is what? Negative. The guy's this thing is increasing, but the lady is decreasing. This one is what? Is in the negative relationship. So for the positive, the two will increase or the two will decrease. But in the negative, one is increasing, one is what? Decreasing. So in our classroom activities as students, okay, if it is expected that we spend a lot of time on our studies, but when the results comes, we expect that when we study more, then the expectation is that the results should give us good results. So when we study for long hours and our results are also getting AAA, then we are in the positive direction. But when you don't study for more hours or you don't go for lectures and then the results are also not good, you are getting D's and the E's, that one too is in the positive because we are not studying, so we are not going to expect good results. So that one too is also in the positive relationship. But when you study for more hours but your results are not good, you are still getting E and D, then it's also in the negative, it's in the negative direction. In that sense, there's a challenge. So these are the things we are going to do. Are you with me? So these are the things we are going to do. So like I said, the guy's height, the person's age, and the person's height. We are going to look at how that will be the nature of it. So we can use those things to draw what we call the scatter plot. And so let me quickly give you a data on the table and then look at how we can use it to calculate the regression analysis here and there, the regression equation. So let me give you this. Very often there is the need to relate a variable of interest called y, which is also known as the response variable. Because the response variable is also known as the dependent variable, to one or more or one predictor. The predictor variable is also known as the independent variable. So take note from me that what I'm saying is that the response variable is the dependent variable, and then the predictor variable is also known as the independent variable. Okay? So in order to build an equation that can be used to describe, predict, and control the response variable on the basis of the predictor variable, when we do this, we are going to get a linear equation. And this linear equation we are going to get is a linear prediction equation of y in terms of a single variable x. And that is what we call the simple linear regression model. And that model is of the form y is equal to a plus bx. Y is equal to a plus bx. In this sense, this y is the dependent variable, or what we can also call the response variable. Now, the A here is what we call the y-intercept. The B here is what we call the gradient. And the X here is the independent or the predictor variable. So you may get the model in that way, and that is it. And so we can use this to construct a scatter plot. So you can use the data to construct a scatter plot and draw a straight line fitted through the middle of the points. So when you draw the scatter diagram, we can use it to construct or draw a straight line fitted through the middle of the points. This straight line is called what we call the least squares line of regression. It's what we call the least square. This straight line is what we call the least squares line of regression. Okay. Of y on x. Of y on x. And so I've given her that equation and I said that one is y is equal to a plus bx. And I've defined the terms in them. Okay. Now, as we move on, the values of a and b, these values here, the values of a and b will be the values that we are going to determine. Because of course, the y values will be given, the x values are also going to be given. Okay? But our focus here is to determine our a and the b. And therefore, we are going to use these two equations. The equations are summation of y is equal to a times n plus b times summation of x. So let me name this one as equation 1. Equation 2 is summation of xy is equal to a times summation of x plus b times summation of x squared. And this one is equation 2. These two equations are what we call the two normal equations. The equations are the two normal equations, of which the n here talks about the number of observations. The number of what? Observations. So we are going to use some manipulations. We are going to use some mathematical manipulations here to get the values for the a and the b. Okay? So from this equation 1, we can divide through by n. So if you divide through equation 1 by n, then we are going to have this, then that. Of course, when we do that, you are going to have summation of y over n is equal to a plus b times summation of x over n. And you will notice that when we have the summation of y divided by the number of observations, that gives you the y cap. That is the mean of y. And so the mean of y is going to be a plus, you know that we have b here, and then summation of x over the number of observations is also going to give you the mean of x. Okay? So in other words, we are going to have an equation like that, and this one is going to be used to satisfy the coordinates x bar, y bar. And from this equation, we can easily deduce that a is equal to, we can easily deduce that from this equation, y bar equal to a plus b times x bar. We can easily deduce that a is equal to y bar minus b times x bar, making a the subject from this equation. Okay. And then from here, that is from the equation 1, we've been able to build an equation of this form to get the x bar and the y bar. Okay. Now let's consider from the equation 2 what we can also get. The equation 2 is of the form summation of xy is equal to summation a times summation of x plus b times summation of x squared. So this is the equation 2. And so here too, we can get b to be a certain form. When we want to get b, we are going to divide both the numerator and the denominator. Okay, but before that, we can say that b from here, if you want to simplify for b here, if you want to make b the subject, then the b is going to be n times summation of xy minus summation of x times summation of y divided by n times summation of x squared minus summation of x all squared. That is when you want to, you can deduce b from here, and that is going to give you the answer if you want to solve for b here. And so we can do other manipulations. So this is the b. But if you do other manipulations, it means that if you want to get other using the variance and the covariance method, then through that we are going to divide through by n squared. We are going to divide both the numerator and the denominator by n squared. And when you do those mathematical manipulations, eventually you are going to get b to be of the form s is divided by x that. Okay? And so when it comes like that, we are saying that the x substitute xy is what we call the covariance. What we call the covariance. This one becomes the covariance. That is the x is. And then this one also becomes what we call the variance of x. This one. That is the s substitute this becomes the variance of x. And I think this word variance, it's not new to you. When we're talking about measures of scatter or measures of variation, we mentioned the variance and the standard deviation. So these terms may not be new to you. Okay. So eventually we are going to get our b. If you multiply this one, dividing both numerator and denominator by n squared, then that is what you are going to get for b, to be the b. And so now that we have these ones, we can set for we can look for a question and then move on. Okay. So we are going to give examples and then use that example to do other things. So like I said that this table on the board, they want us to use the table to calculate the equation of the least squares line of regression of y on x. Calculate the equation of the least squares line of regression of y on x. Remember the question is y on x, which means that y is dependent on x. Y is dependent on x. So in that sense, if this is the question, then what you need to do is that you are going to create other columns. You add other columns, of which you are going to add a column, say xy. And then you will need x squares. Because it is y on x, the x is the independent variable and the y is the dependent variable. So y on x, that is the implication. So if that is the case, we come to the table and have xy, we are going to get x squared. Okay. Then let's square these values. So 2.8 squared, let's find xy first. That is 2.8 times 7.5. And that gives you 21. 4 times 9, that is equal to 36. Then 5 times 10 is 50. Then 3.5 times 6 is equal to 21. And then 4.5 times 9 is equal to 40.5. Then 5.2 times 12 is 62.2. Oh, sorry, 0.4. 62.4. Then 4.3 times 11.3 is going to give you 48.59. Okay, and then 5 times 10, we know 5 times 10 is 50. 2.5 times 7 is equal to 17.5. Then 3 times 8 is equal to 24. Then when we come to this column, we are talking about s squared. So we are going to square the s value here, put it there. So 2.8 squared is going to give you 7.84. Then 4 squared we know is 16. When it comes to the whole numbers, we don't have a challenge. But the decimals may be a challenge, but we will still do that. And then 5 squared, we know 5 squared is 25. 3.5 squared is 12.25. Then 4.5 squared is 20.25. Then 5.2 squared is going to be 27.04. Then 4.3 squared is going to give you 18.49. I think so. And then 5 squared is 25. 2.5 squared is 6.25. Okay, and the last one, 3 squared, is 9. Okay, so if we have these values there, then what we are going to do is that we are going to have summation of x. So we add all these values and put it there. And summation of x is equal to 39.8. Then we sum the y's, and that one is giving us, that is summation of y, is also giving you, when we do that, 89.8. Then we sum summation of xy, we sum everything here, and that one too gives us 370.99. And then we sum the last one, that is summation of x squared, and that is giving you 167.12. You don't say 167.12, it is 167.12. So when we are done with that, don't forget about, we can go by them in two ways. So we can put them using the two normal equations. We can put them in the two normal equations. And so for the first normal equation is that summation of x. Okay, so that one we are going to have, what is the first normal equation? The first normal equation is that we have the first normal equation to be so we are going to substitute the values that we have gotten here into the two normal equations, or there are two options, so we can use that idea. And so the first normal equation, that is y on x, is going to be summation of y is equal to an plus ab times summation of x. Okay, and then the second one is that we are going to have summation of xy to be equal to a times summation of x plus b times summation of x squared. And so we are going to substitute. If this is one is equation 1, this is equation 2. Let's put them in equation 1. For equation 1, summation of y is giving us 89.8 and is equal to an. A I don't know, but n is the number of observations. So how many observations are involved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives you 10a plus b, I don't know. But I know the summation of x. And what is the summation of x? 39.8. So this one gives me, if you want to rewrite this one, you can have 10a plus 39. This one will be 39.8b is equal to 89.8. Let me name this one as equation 3. And then I'm going to also substitute into equation 2 to get another form. So in equation 2, a summation of xy. Summation of xy is what? 370.99 is equal to a, I don't know, times summation of x, which is 39.8a plus b, I don't know, but I know summation of x squared. The summation of x squared is what? 167.12b. And so I can name this equation as equation 3, equation 4. So I'm going to solve equation 4 and equation 3 simultaneously. And when you do that, equation 4, equation 3 simultaneously, when you solve those two equations, you know how to solve simultaneous equations. Then eventually, you are going to get your b to be equal to 1.56. And so when you get the b to 1.56, then we substitute. What are we going to do here? Okay, we can make one of the variables the subject. We know that. We can go by elimination, we can go by substitution method. So we can make one of the variables the subject here. And when we get it, we come and substitute into this equation. and then look for that. So I think we made A the subject into this and substituted into that, and through that it will yield to the B. And so we get the B to be equal to that. And once you are putting the B to be equal to 1.56, we can substitute that value also into any of the two equations. And when we do that, we are going to get our A to be also equal to, A is equal to 2.78. Okay? What I said was that for the two equations, we solve it simultaneously. We know how to solve simultaneous equations. So we make one of the variables the subject and substitute into the other. And through that, we did that and we got the B to be that. And when we are putting the B to be this, you then go and substitute the B into any of the two equations to get your A. And that the A is getting B. Remember, the equation of the regression line on X, Y on X is A plus BY. A plus bx, that's y is equal to a plus bx. So now what is your, we don't have our y to be equal to, what is your a? Your a is 2.78 plus, what is your b? 1.56 times what x. So this equation becomes the equation of, the least squares line of regression on y is equal to that. Okay, the least squares line of regression of y on x is this particular equation. Now what is this one telling us? Now what is this one telling us? Like I said at the beginning, we can use this regression line to make predictions. So y is equal to 2.78 plus 1.56x. What is this telling us? When we come to the x values, a value of x should give us something. But now we are assuming that we are going to pick a value, any value which is outside the values that we have been given. So we are going to use it to do a prediction. That if I have a value of say 2, no 2 is not captured here. If I have any value which is not necessarily here, and I pick a value of say 2 and put it for x, what will be its corresponding value of y? What will be its corresponding value of y? So if I substitute 2 for x, then I'm going to get 2.78 plus 1.56 times 2. And so when I do that simplification, the answer I get will be the y value. So when the x is known, we should be able to use that one to get your y. That's why we are saying that before we can get x, before we can get y, x must be known. And so when we do that, we are going to do that one to do prediction. And that is how we can do that. Now, there's another way we can do that, and that one I'm going to give it to you now. Okay. Remember we said earlier on that the b, when we manipulated the two normal equations, we said that the b is equal to n times summation of xy minus summation of x times summation of y divided by n times summation of x squared minus summation of x all squared. And we also said that the a is equal to y bar minus b times s bar. Okay? Because we are saying that we have an equation equal to a plus bx. Okay. So instead of us using the two normal equations, I also go by it in this way. That one to get to the answer. So it means that when we come there, we have the b to be equal to n is the number of observations. So how many observations are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times summation of xy. Summation of xy is equal to 370.99 minus summation of x. Summation of x is 39.8 times summation of y. And summation of y is also equal to 89.8 divided by n times summation of x squared. So what is summation of x squared? This one. 167.12. Okay, minus summation of x all squared. So when we sum all these x, we've got 39.8. So So that 39.8, we are going to square that one. And so we try to simplify. So let me pick my calculator and try to simplify. So I'll have 10 times that. Of course, if when you do that, I think we are going, you know that we are going to get 3709.9. Multiply this one by that. Minus 339.8 times 89.8, and that gives you 35,704.04 divided by 10 times this value, and that's going to be 167.1.2 minus 39.8 all squared. So 39.8 squared, and that is 15,804.04. Okay, and so when we simplify, then what are we going to get? The numerator is going to have 3709.9 minus 3574.04, and that gives you 135.86 divided by, then we also have 1671.2 minus 1584.4, 84.04, and that is giving you 87.16. So let's divide this 135.86 divided by 87.16, and that gives you, are we doing the right thing? Let me do my estimation again. So I have 167.1.2 minus 1584.04, 87.16. Okay, so 87.16, we have 135.86 divided by 87.16, and that is 1.5587, and so this one is approximately equal to 1.56. Okay, so if I have 1.56 for B, then I can now come here, look at it here. If I have 1.56 for B, then I can now come here and insert it into that. So it means that in A, if I want to get A, what is Y bar? Y bar means that the summation of Y divided by number of observations. Remember, the number of observations are what? 10. So you have 89 divided by 10, and that gives you 8.98. Okay? Minus B, I know 1 point, let me use 45 for this man, please. 15587 times the X bar. And what is the X bar? That one is going to give you 39.8 divided by 10, and that gives you 3.98. So if I simplify this one, I'll have 8.98 minus 1.5587 times 3.98, and that gives us 6.2036. And when we take away that one from 8.98 minus 6.2036,
2.36, and that gives us 2.7764, and that one is approximately 2.78. Okay, so if that is the case, then it means that in our equation, y is equal to a plus bx. We are going to have y is equal to a 2.78 plus b 1.56 times x. So you do that, you get the same answer as how we did for the first one. So please, we can go by the two methods to get our answers. Okay.